It's got a uniform ladder, rests on rough ground against a smooth wall, like so. And a man of 6W can stand somewhere on it. So let's put the weight coming straight down. We've got normal contact force here, so I'm going to call that R for the base. And we've got friction as well because it's rough. That'll be going inwards. We've got normal contact force here. I'm going to call that RT for our top of the ladder. That's at right angles. And there's no friction here because this wall's smooth. I've got to put 6W in there, so I'm going to put the man standing on here. 6W. And it says that that is a distance of the whole distance going the whole way up there is 2A. And this distance here for the man, that distance is X. So this distance here is X. And we're given the angle is theta. And we're actually told what sine theta is. Sine theta is 12/13. So it's a 5, 12, 13 triangle. So that means that cos theta equals 5/13. I might need that. So there we are. And we have to show the magnitude of the frictional force. So we have to work out what F is. Well, fairly obviously, if I resolve horizontally, we get rightwards equals leftwards, and that says that F is the rightwards equals RT. So that means I actually need to find out what RT is, and that's going to be easier to do that. Find out RT, I can get rid of a load of this stuff and get rid of this one and this one by taking moments about the bottom, which is A, top bit is B. So I'm going to take moments about A, and I'm going to have anti-clockwise equaling clockwise. And so what goes anti-clockwise? Taking moments about A. Well, obviously the RT bit at the top. So the RT times by the distance. Now the distance we're talking about here will be, I'll highlight it and then I'll get rid of it, will be this distance there will be the thing. So that's a line of action going across here. And then we need to times by that distance there. That's 2A. Actually, this distance here is exactly the same as this distance here. And so it's 2A sine theta. Okay. So we got, that is times by 2A sine theta. And there's nothing else that way. And then anti-clockwise, we've got the, clockwise, we've got the 6W bit. So we've got 6W. And that's X there, so that's this distance here I want, which is X cos theta, plus the W bit. And the W, it's times by the distance going across here, and that'll be A cos theta. And so that RT times by 2A times by sine theta, which is 12/13, so that'll be 24A over 13. That equals cos theta is 5/13, so that will be 30WX over 13 plus cos theta is 5/13, so that will be 5WA over 13. So that means that RT times by 13 gets rid of that, equals top bit, so 30WX plus 5WA all over 24A. And this now I want to see what it looks like. So RT equals, I take out 1/24th, so it gets rid of that 1/24th. And take out 5W as well, so I put 5W on top. And that bit's, well, should we do the first one? We want the first one to be 1. That's obviously going to be here. I've taken out 24, taken out 5W. I'm left with A over A, so that's 1, but that's this bit. And then plus, I've taken out 24, so I've still got to have the over A bit here. So I've still got to have the over A. And 5W, I've got to times that by 6X to get that, and so it's worked out what RT is. Therefore, F equals this bit, because I've resolving horizontally. So that's the first bit done. Now I need to work out the second part. That's 5 marks. Coefficient of friction is mu, so mu is 1/3. Find in terms of A the greatest value of x for which a system is in equilibrium. So it's an equilibrium. I'm going to do F lim equals mu r, and because I need to know what mu is, I need to find, I've worked out what F is, I now need to get what r, so I'm going to have to resolve vertically, and that says that up equals down, and up is RB, and down is W plus 6. I've got RB equals 7W, and therefore F lim is 7W over 3. It's got that bit. And now I know what F is. F is this bit here. I've got to just set it equal to that. So I've got 5W over 24 times by 1 plus 6x over A equals 7W over 3. And obviously W's will cancel out. And that leaves us with 525, multiply out 5/24 plus 30x over 24 A equals 7/3 times everything through by 24, so that'll be 5 plus 30x over A equals, that way times by 24 will be the same as times by 8, 56. Subtract 5 is 51. And I want to know what x equals, so that's going to give me x equals 51 over 30, and that'll be A there, so times in both sides by A, and that works out to be exactly 1.7 A. So it's done that bit, and now finally it's the bottom of the ladder has moved closer, so it's much steeper now, well, at least a bit steeper. And it's like this, so that's now alpha. We've still got our things, but the man can now stand right at the top. So man can now stand right at the top here. We've obviously got RT at the top there, and we've got here, we've got RB, and we've got F, and we've got, that's all our forces on there, that's A, B, and I've got to work out what tan alpha is. Well, it's definitely going to be a moments type thing, because otherwise resolving it's not going to help me. It's going to say RB is 7W and RT equals F. So it's definitely going to take moments. I'm going to take moments about B, because if I take it about B, then that's going to get rid of this 6W here. And I'm going to have anti-clockwise equals clockwise. So I've got, start off with this W times by the distance. It's going to be times by this distance here. That's A. So this distance here is A cos alpha. And there's nothing else which is... And also this is F here. And I've worked out what that F is. So that's going to be F is 7W over 3. So 7W over 3 times by this distance here, which is 2A, and it's 2A sine alpha. 2A sine alpha, and that equals RB, which is 7W. So it's 7W times by this distance here, which is the same as this distance here, which is 2A cos alpha. 2A cos alpha. A bit small there. And so if I multiply that out, that gives me 14A sine alpha over 3. That's this bit here. Equals, and I've got 14A W, or W's cancel out, W's, all those W's cancel out. And so that gives me 14a cos alpha here. Take away a cos alpha. That equals 13a cos alpha. So I divide both sides by tan cos alpha. That will give me what tan alpha is. That's marvellous. Tan alpha equals 13 times by 3. The a's cancel out, of course. So 13 times 3, divide by 14. So tan alpha equals 39 over 14. And that is question 5 done.